In the next 20 minutes, I'm going to talk you through a comparison between Lambda and step function. Just to make sure we know what we're talking about, raise your hands if you used Lambda before. Quite popular, was expecting that. Have you used step function before? Good. So hopefully I'm not going to say anything wrong. If I do, please come and tell me after. Just to make sure we're all on the same page, I'm going to quickly run you through the AWS definition taken from their documentation. What is a Lambda? It's a serverless event-driven compute service that runs your code. It's literally triggered by anything under the sun, API gateway, Dynamo stream, you name it. And it supports a variety of coding languages like Node, Java, Python. You can zip your source code and upload it, or if you really want to use Docker, you can. Not sure why you want to do that, but your choice. Step function, it's another serverless service. It's a workflow, I can speak if I want to, service that help you orchestrate your application and use visual tools for it. It's mainly composed by two parts. One is the state machine, which is your workflow itself. State machine is triggered by a bit less event than the Lambda. API gateway, event bus, you could potentially have a Lambda invoking the execution API or from another step function. And the other component is states. State machine states, kind of makes sense. States are your task, and AWS provide a library of already created tasks that interact with their services, like Lambda invoke, DynamoDB, and so on. Every state comes with an input and an output, which means you're able to control how the data flow through your workflow. Looking at that, you might be wondering, why are we trying to compare them? They do not look like the same similar service. It's like compare pear and apple. The answer is you can use both to solve the same problem, which is get me a snack, clearly. This is what we're going to do now. So our use case for today is you're going to get tasked to build an order fraud check service. So you're going to receive an event with an order created, and then you're going to make a call to a third-party provider that's going to establish if your order is likely to be a fraudulent order or not. And then you're going to take that response and put it on the bus so the order can continue its journey and be fulfilled by some other application downstream. You're happy to receive duplicate event. Downstream are also happy to receive duplicate events. Your third-party provider is not happy with that, so you need to make sure you do not send the same request twice. We learned before there's something called idempotency, which gives me headache just thinking about it, but I'm going to look at power tools later. What I did for this talk is create a DynamoDB where I store my order number and my fraud status check, so I can check against it before I call my provider. This is high level what we're going to do. So we're going to take a step further down to make something complex less complex and look at all the steps we'll have to perform. This is the task that our code has to do. You're going to validate your event, then you're going to check Dynamo, and if you do have a record, you're going to take the result to put it on the bus. If you don't, you're going to transform your event to create a fraud request that your provider accepts. You're going to call your provider, store the result in Dynamo, and then put it on the bus. A couple of caveats about our implementation. This is a use case I made up. So your service is going to be invoked by an event from the default bus. Your third-party provider doesn't exist. That doesn't mean it doesn't exist in real life. So don't go off and steal credit card, because somebody's going to check. But for our use case, I built my own API gateway with a Lambda that tells you yes or no, basically. And my API gateway has no authentication. It's free for all, bad practice. It's an AWS API, but we're going to pretend it's a third-party URL for our step function. We're going to look into this later. And I use TypeScript in an AWS CDK. If you're not familiar with these languages, it doesn't really matter. We're going to look through the code, but it's more about principle. So let's get started with your Lambda. So you get given your task, and you look at your steps, and you think, OK, this is fairly straightforward. You know what? I'm just going to stick everything in a Lambda. It's going to handle all the logic. I'm happy with that. So your handler is going to do the heavy lifting of the code. That means your stack is going to provide provision your Lambda. Then you're going to have a bus rule that triggers your Lambda and provision a DynamoDB table where you store your record. If we look into the code, we say the handler is going to handle everything. Depending on your code preferences, you can stick everything in one file. You can have multiple files. You can import your function, whatever you like. For myself today, I decided to create a tiny AWS util file where I create all my SDK client and I interact with Dynamo and the event bus. And then I keep my fraud service file for the main logic of my handler. And the main logic is going to be driven by if statement. I have like a variety of them. So I'm checking if my event is valid. Then I'm calling Dynamo. I'm checking if I'm getting a result. Then when I call my fraud provider, I'm even checking if the response actually return a status field, just in case I get a 200 and it's empty, and I can't get on with my life. And I'm just going to quickly draw attention to those two steps. The validation and transformation are very dumb here, because it's a made-up case I made just for this presentation. It's not real life. In real life, your transformation specialist is likely to be more complicated. You might need to do string manipulation, add field, remove field, and so on. But for this purpose, I keep it nice and simple. So you build your handler, you put it into prod, and then sometimes, never with my code, but it might be that an alarm goes off, so your Lambda is throwing an error. So to help yourself troubleshooting, what you can do is add logs. And because there's several points where your code can go wrong, what you might want to do is create a message in your log that tells you where you are. So in this example, I've wrapped my put item Dynamo function with a try catch, and my error says, error created your item in Dynamo. So I know where I am in the flow. So I don't have to go through and see, did that work, did that work? I know what is throwing an error. Alternatively, you can add like a console log that tells you, okay, this step performed successfully. I kind of don't really do that because honestly, you're never going to look at your logs unless something goes wrong. And at that point, you're going to look for the error message, not for what went well. It is good sometimes to use it when you need to log maybe a specific field. It's going to help you troubleshooting with other application. So in this case, you might want to log the order number because you can call your colleague from another team and say, hey, what event I've sent you for this order. Part of your failure could be that one of the services you're interacting with is unavailable. But we know that sometimes there's a glitch. So you call Dynamo, it's unavailable now, and then you try again and it works. If you want to do that, you kind of have to build a whole mechanism that thinks, okay, I got a service unavailable, wait for a second, try again. But you can't be trying again forever, so you have to count how many times you try and decide to stop at some point. And that was giving me a headache, so I was like, no, I'm just going to run without. Amazon never goes down, really. And if my third-party provider is down, I want to know so I can ring them and say, hey, your service is unstable. So that's our handler. Quick look at our stack. We did say it was going to be very simple. I'm going to point at this screen. So you're going to provision your Lambda, you're going to provision your table, and then you have an event bus rule that trigger your Lambda. And then bonus content, permission. So because you have to interact with AWS services, you need to make sure you give your Lambda the right policy to talk to the right table and the right bus, and restrict the action your Lambda can perform to what you really need. Cool. So that's our Lambda done. Let's look at step function. Let's remind ourselves of what we need to do. Those are our tasks. And if you remember, I said that some of the tasks of the step function already integrates with the AWS services, namely DynamoDB. So that task can be done by state without any other code. Likewise, you can get item. You can also put item to Dynamo. And you can also talk to the bus. And funnily enough, even if it's not AWS services, there's a state that lets you talk to a third-party API. So you can see from this chart that the heavy listing of your code this time can be done in your stack by your state machine. And you're left with validate and transform event. Because my validation and transformation is very dumb, I can probably get away with input-output transformation. But in real life, this is not the case. So what you're going to do, more likely, is to create a Lambda that transform your logic. In this case, I have one Lambda that validates the event, and if it's good enough, it's going to return a fraud request directly. That's because I don't need anything else. In real life, you might need fields that get generated from other state, so you might need to provision two Lambda. But the code is going to be very simple. So your stack is going to be kind of the same, because you still need to provision your Dynamo, you still need to provision for Lambda, even though the code is going to be that long. You're going to create your state machine, and then the bus rule that invoke it. We did say, though, that state machine is good because it has a visual tool to show you what it does. So once we built all of this, you go to the console, you go step function, state machine, and this is what you find. A beautiful flow chart that tells you what's happening in your code. So you can see all the branches, all the choices. That's a good time to remember that when you name your task, you want to give meaningful names. Because if you call them task 1, 2, 3, 4, you look at this chart and it's useless. So bear that in mind. We love naming convention and naming things in software engineering. How do we get to this point? Well, first we're going to build the source code for our Lambda, which is literally that, 10 lines of code. I'm just going to mention this because here, if your event is not valid, instead of throwing an error like we did before, we're going to return a different message. So your Lambda is going to return an output in any case, and then it's a state machine that's going to it's going to act depending on the result that you get from the state. So the state machine is in charge of orchestrate your flow. So let's go and build the state machine. This will be your stack. State machine, if you want logs, you have to enable them. Then you kind of have to define the type of the state machine. There's 2 types, standard and express. They're slightly different. I'm not going to go into it because I don't want to tell you something wrong. But the main part that you need is this, definition body. And this is where you tell the state machine all the tasks and how they chain together. And now I've been a bit cheeky because that line doesn't tell you anything, because this is normally what you do at the end of your stack. Because here you have to define all your tasks. Unless you literally have 2 tasks in your state machine, you're not going to do that in the state machine definition. You're going to define your variable, your task before, you're going to chain them, and then here you're just going to point where to start. Sorry. We'll get to that, though, at the end of the talk, so don't leave. You will have to create a rule that invoke your state machine instead of a Lambda, but same concept. And then even though the state machine integrates directly with the AWS services, you still have to give permission, so don't get fooled. Here you can see my Dynamo and my event bus permission, and there's a couple of other things that are actually needed for the call third-party API. We'll look at them later. So let's start creating tasks. This is how we start our step function. We call the event handler, as I called it. It's going to be a Lambda invoke. You're going to tell it, call this Lambda. And then I'm going to start leveraging the input-output that I was telling you about. So you can use this result selector, which shockingly select your result. So you can decide what you want to pass on to the next state. So every state will have its output from the task performed, but also has a wrapper about the state itself that I'm not interested in. So this time I'm saying, you know what, just pass on the payload that my Lambda returns, and I'm going to put it on a field very creatively named payload. And then once I select my result, I need to tell the state machine where to put it. I'm using this result path, which is what it does. And you can see I have this thing called state data.event handler task. So I'm going to use this structure all across my state machine. So I'm going to create an object called state data that gets appended on the input, and then it goes out as an output. So your output will be all the input plus the state data object, the name of your task, and then the result of your task. And that allows you to have consistency. So if you need a property from another state, you know where to find it. It's going to be state data dot the name of the task, and then the name of the field. Another task is going to be interaction with Dynamo. This is the get item call. Very easily you have to put the query you want to run, the table you want to query. I'm selecting my result. And I'm going to point out this add retry functionality, which is out of the box for step function. And it does what it says. So I'm saying, if you get one of these 3 errors when you call Dynamo, retry before giving up. And you can select how long you want to wait for before you retry. You can select how long you want to change your waiting time. I'm going to give you an example because I can't explain it in English. So you have, by default, 3 retries. So it's going to wait for 2 seconds. And then if you get a failure, it's going to wait for 4 seconds, because the back-off rate is 2, and then for 6 seconds. So you can leverage it. You can select less than 3 retries if you want. But this is very good because if you call Dynamo is unavailable, your state machine will fail. But if you have a retry, it might recover and then succeed in the end, which brings the number of your error down. The state machine is going to fix itself. And then you can just keep drinking your coffee, and you'll never know. And then I want to mention this task, the call third-party API, because it's a bit special. As you can see, it's called custom state. So you're kind of telling the state machine you're going to make up your own task, but you can't go rogue and do what you want. So you have to select one of the resources available, which is a state called HTTP invoke. So you're basically saying, that's my custom state. I want you to perform an HTTP call. And once you've done that, it looks like a normal HTTP call. So you need your URL, you need your method, you need your body request. And then you kind of need this. So AWS thinks that, rightly so, you should be authenticating when you're calling someone. And to do that, you have to create a connection. This is some resource that you get actually from EventBridge. You create a connection, and you're saying, when you make this HTTP call, use this connection. And the connection requires an authentication. And because my API, is free for all, I don't have one, but I still have to provide something. So I create a basic authentication username and password, and you can see it's a fake user and a super secret password. But for that reason, your state machine needs permission to call secret manager and the connection. So now we build all our tasks. If you remember from our Lambda, we have an if statement. How do we handle if statement in the state machine? Is by creating something called choice. Choice is a type of task, and then you use a condition, and you basically say, if this condition is verified, perform this task. Otherwise, these are the tasks. Condition gives you a variety of operators. You can have string equal, number equal, greater than, less than, everything you want, present or present. You can combine them. So in my first example, I'm checking if my status code is 200. I could have, if the status code is 200, and then this field has this value. So it gives a lot of flexibility in your logic. And then here I'm going to point out this called valid event branch. So either I'm very bad at naming my task, or here I'm calling a branch. So we're going to look in a second what I'm talking about. If you remember, this is what we're trying to build. So we got to the point where all our tasks defined, all our choices defined, and now we have to tell the state machine in which order they need to be performed. Not going to lie, keeping the stack clear, it's a challenge. So I'm going to give you some tips how I normally do, and then you're free to experiment. But remember that the value of the state machine is the flowchart. So you can concatenate tasks using those .next. So I'm starting and creating the start of my state machine here by saying, go event handler, and then do is event valid. You could potentially chain like 10 tasks if you want, but my second task is a choice. You cannot .next a choice for obvious reason, because you don't know where you're going. So what I do in this case, well, I have to stop there, but then if I look at this side of the state machine, this choice, I have two tasks that concatenate together. So I create my valid event branch. They actually call the first one and then the second one, which is, again, is a choice, so I can't go on. But that's the idea. You can try and combine all the subsequential tasks in branches and then feature them. Kind of keeps the code clear, but it's a lost battle, if you ask me. Another thing you can do is when you define a task, you can chain them right at the bottom by just doing .next. So this is a definition of this one here. It's a pass. Pass is another type of task where you just add a parameter and you do a bit of kind of data manipulation. And because the last thing I have to do after that is put event, I'm just going to chain by .next, put event task right there and then with my definition. And this is our state machine. So we made it. We go in production. And guess what? You get the alarm going off. So state machine offer a nice tool called execution log, which gives you this. So you can go in the console and see for every execution which task has been invoked. And you get a nice color coding, green, pass, red, fail. So this is my epi path. I get my order, I call my fraud provider, I get my message back, all good. This is not so good. So I got an event that didn't pass validation. So I go 1, 2 tasks, and then, sorry, fail. And the good things about the execution log is that you can highlight the task that you want, and then on the right side, it will tell you the input and the output, the state received, like it's shown there. So this is my is event valid choice, got an input that came out from the Lambda saying 400, and then I know I have to go this way. This is very good when you're building, because if your choice is wrong, you will find immediately that your state machine is going to the wrong branch. Never happened to me before. Note of caution for the execution logs. They will log literally everything that goes in your state machine. So if you have sensitive data, you might need to either enable them. There are other ways to then troubleshoot the state machine, not part of this talk, X-ray, for example. Or you might want to choose a very, very short retention period. And that's us done with both. So now you're going to sit there waiting, okay, Clara, so which one should I use? There's no answer to that. Sure you saw that coming. Everything in software engineering, it really depends on your use case. There's no one size fits all. And for the record, one size fits all, it's a lie. You know that. So I'm just going to try and recap and give you some pointer on how to choose. So first thing you're going to look at is complexity of your logic. So we say if your logic is kind of straightforward, you might have a couple of if statements, but you can handle it, you're going to go Lambda. If you have loads of them and you have nested if statement and it makes a mess to follow up your Lambda code, you might want to lean towards step function because you can have your beautiful flow chart and see what's going on. Other side of the same coin is the troubleshooting. Again, if something goes wrong and your code is nice and neat in your Lambda, you can follow through and find out where it goes, and you're just going to add a couple of logs here and there, and it's going to help you out. If it's very convoluted and very complicated, then you can rely on execution logs when you're just going to see instantaneously which step failed because it's going to be bright red in your execution log. Number of interaction with other services. As we saw, if you have a lot of them, you might incur into this service unavailable or try again error. So if you have a limited number of services, you can go Lambda because you can do your error handling nice and easy. Maybe just a couple of them. Maybe you just talk to AWS and it never goes down. If you have lots of them, you want to try and leverage the retry functionality you get out of the box from the Lambda. This is my favorite, scalability and maintenance of your code. So you always have to ask yourself, whatever works today, will it work tomorrow? Because now you're going to sit here and say, okay, Clara, you make such a big fuss, but your Lambda is good enough. It's like 3 steps, you can handle it. Yes, but what if tomorrow you open a new market and your third-party fraud provider goes, oh, well, we have different algorithms per country, so if your order is in Australia, you call this endpoint. If it's in Japan, you call this other endpoint. That adds a layer of complexity. And then your business turns around and said, we pay for fraud prevention, so for any order that's below $20, don't bother. It means when you receive your event, you have to do another filter. So your complexity keeps increasing, and your Lambda, you keep adding stuff left, right, and center, so at some point, it might just be out of control. While in your step function, you just add another choice, another state, another branch, and you can follow through. There is a margin for the step function as well. You can just grow in this monster, and it doesn't fit in your screen anymore, but there's a long way before you get there. And then I have a couple of points that we haven't really seen in our implementation. One is the purpose of your code. So why are you writing this? Is that my own personal project? I'm checking when the bus is coming or whatever. I'm going to be the only one using it. So even if I write a Lambda that is convoluted, I'm going to be the only one dealing with it. Hopefully, if I go back in 6 months, I know what I've wrote. Do you work in a team? Do you have to onboard new people? How easy is it going to be for them to understand the logic and be able to contribute? Cost? I literally have no idea about cost. But it's important, and when you have to choose a solution, you have to budget for it. You have to count how often you're going to use the service, how much it costs, and cost is not the only thing you consider, but it's part of the equation. And sometimes you can have a bonus point. If you're cost efficient, means you're resource efficient. If you're resource efficient, you're not wasting resources. Eventually, it's greener for the planet. So bonus there. And then this one that I got out from the internet, so I hope it's right. You should not believe everything that's on the internet. How long your code runs for? Your Lambda is going to time out after 15 minutes. No matter what you do, that's the maximum. So if your code has to run forever, you might want to think about step function. Like, apparently, it does run forever unless you set a timeout to it. But the other good things about step function is that you can run tasks in parallel. So if you have to run 10 tasks and then there's an 11th one, but those 10 tasks are not in a sequence, you can just make them all in parallel, and when they're all completed, you move on. So then it saves you time. And that's the end of our talk. There's a QR code to the GitHub repo if you want to look at my code, but don't know why you want to do that, but some example.
Thank you, Clara. We have some time if anyone's got questions. Sheen. Ooh.
Sheen.
Is Sheen allowed to ask a question?
Well, Sheen can answer this question.
And just the last point, the timeout.
Yeah. Is it true?
No, step function. If you choose standard, you're okay for a year. But if you
Yes.
choose express, 5 minutes.
Also, if you reply to an API gateway, I think times out after 30 seconds. So don't go wild with the retry either.
Yeah, okay. 29 seconds for REST API, 30 for HTTP.
If you have a question, ask Sheen.
Really? There's a difference between the two, 29 and 30. Yeah, that's interesting. A bit of a nod there from Benjamin. Any other questions? Oh.
You mentioned the step functions can get more sort of larger and complex and sort of spaghetti-like. Is there some guidance as to the number of steps a step function have from a best practice perspective?
It really depends, because you might want to try, if you have like common task, to be like the higher level, you just follow, and then you put the choice only when you have no common code. But let's say you run a payment step function, and then you start at the beginning, and you say, okay, we validate the event, the validation is the same for everyone. That's another step that, I don't know, checks the amount is for everyone, and then depending on your payment method, you go different route. That seems to be clever. But then when you start having a lot of sub-branches, you might think, you know what, even if we do have common code, it's easier if I split it, because then every payment method will have its own flow, as the repetition of the code by makes it easy to read. So it really depends when you build your step function. When you look at the flow chart, if you can follow, it's fine. If you can start saying that I got one branch here, and then it goes this way, and then comes here, and this one does that, then you might think, okay, I can't read it. But it's like everything is not really answer, but this probably, I'm sure there's pattern out there I'm not aware of.
Naming probably helps too, right? That's super important. I've seen some pretty bad state machines with some weird namings.
You can decouple and have state machines for state machines too.
Yeah, you can have like nested state machine as well.
Any other questions? Anyone? We have a couple more minutes. No? All right, we'll have a small break, and then we'll have Nellie up next. Thank you.
Thank you.